Hello children, welcome back to our next chapter. Now we will start second chapter of physics, and that is force and acceleration. Before starting this chapter, let's recall what is force. We have discussed this chapter in junior classes, class 6 and 8, that force is a fundamental quantity which tries to bring some type of changes on the size, shape and position of a body. That means force is responsible to bring any type of motion or rest on a body. So before discussing about force, let's discuss about the position of a body. A body has two type of position. Either it is at rest or it is at motion. In both cases, this property anybody want to retain forever. That means if a body is at rest, it want to remain at rest. A body in motion want to remain on motion. And this inheritance property of the body is known as inertia. So what is inertia? Inertia is the property of a body. It is property of a body, property of any body by which it wants to remain on its condition of rest or motion. That means a body in the condition of rest want to be at rest. A body in the condition of motion want to be at motion. Suppose we are talking about this board itself. We have hung this board and the board is at rest and it want to remain at rest. Just like the celestial body, they are in motion, they want to be in motion. So that property of a body by which it wants to remain on the condition of rest or motion is termed as inertia. Now we'll move to the types of inertia. Types of inertia. Basically, we have three types of inertia. First is inertia of rest. Second, inertia of motion. And third, inertia of direction. We have already discussed inertia of rest and inertia of motion. A mountain, a tree, a board kept on any surface want to remain on the condition of rest or stays on the condition of rest due to inertia of rest. Same like the celestial bodies and a body moving in no dissipative force area. That means no friction is there, no other various force are there, will remain on the condition of motion. That is due to its inertia of motion. Third is inertia of direction. What is that? According to that, during motion, a body want to retain its direction of motion. That means on which direction it is propagating, the body want to align on that. Just you think when you are moving on your school bus. The school bus is moving. As the school bus is starting, what will happen? You thrown in this direction. Try to recall, it happens. So as the school bus is moving, you throw in this direction, and when the school bus becomes straight, then also again you will straight. With the same school bus, if it is taking the left turn, then you thrown on that direction. Why? Because the body, that is you, want to remain on its inertia of direction. The direction where you are moving, that direction you want to continue, and that's property within that body. Any body is due to inertia of direction. A body want to retain the direction of its motion during its entire journey. So that is the due to property of inertia of motion. So how will measure the inertia? That is, what is the inertia of a body? So factor affecting inertia. Factor affecting inertia. Inertia is governed by only one factor, that is its mass. More is the mass, more is the inertia. So inertia is directly proportional proportional to the mass of the body. Suppose I have two bodies. One is this body and another is this second body. Now both bodies were kept in a parallel. On which body I have to apply more force to make it move? Obviously this body, because the mass of this body is quite very much more than this. So more is the mass, more I have to apply force on it, so the body will move. Similarly, more is the mass, more force I have to apply to stop it, because both are coming. How can I stop both? For this and this body, may I apply same force? Obviously not, because this is a heavy mass, so I have to apply heavy force on it. So the inertia of rest, inertia of direction, as well as inertia of motion, all three depends on one single factor, and that is mass of the body. More is the mass, more will the inertia. Now we'll move to the next condition, that is who breaks the inertia. Who breaks the inertia? So first principle we'll talk about. The first scientist who has given this concept that who breaks the inertia is the Galileo sir. Galileo sir has not given any mathematical expression, but his idea only helps Newton sir to derive all the three laws of motion. So first of all we'll move to the Galileo sir's experiment. Galileo's statement. Galileo sir has designed a framework, and he has told that if dissipative force are absent, that means no external force is applied on a body, the motion of a body will continue as it has started. So he has taken a plane like this one, and what he wants to say that if a body, that is ball is given a rolling motion, the ball will try to attain the same height as from where it has started. If this ball will race, the ball will try to attain the same height from where it has left, if it's a U shape or such a pattern are there. First condition. Second condition, he has told if this surface is inclined little, that means this angle is changed. So what will happen? The ball will cover little more distance to attain the same height. Ball will cover little more distance to attain the same height. So what we are doing? We are changing the nature of this inclination. This time this inclination is disturbed. So what Galileo sir is saying, this time the ball will cover more distance to attain that height. But the ball will try to attain that height if no any external force is stopping it to achieve that height. The third condition, if this plane is changed now, the surface is made flat. The surface is made flat. If this surface is made flat and no external force is working, then according to Galileo sir, the ball will move to such a distance to attain that height. That means Galileo sir wants to say that in absence of external force, the motion of a body will be uniform. In absence of external force, the motion of a body will be uniform. But this law was violated after some years only, because there is no any actual places there where dissipative force are not present. Here dissipative force means force of friction, the gravity factors, and the molecular motion of this body, because the rigidity of body also play a vital role on the motion of a body. Because while motion, the particles of matter will collide with the surface, and that rigidity will get disappear. You've seen in cricket ball, the new ball has little more shiny, but after some time the shine disappears because the layer get corroded, and what happens, the size, the rigidity of that ball will change because due to that dissipative force. But this Galileo sir statement has helped Newton sir to derive all his laws. In our next class we'll discuss about that, but before that we will discuss what is force and how force is related to inertia. Please take a screenshot if you want to take, or pause the video and write down the things. Okay. So how to define force according to inertia? So force is a fundamental factor. Force is the fundamental factor which can change the inertia of a body. So today we have got a new definition of force in terms of inertia. Sometimes a teacher or any senior of you will ask that define force in terms of inertia. That means pushing or pulling effect of force. That definition, whatever we have done in junior class, you don't take that. You define force according to inertia. So what is force? Force can change the inertia. If a body at rest, it is the force only it will bring in motion. If a body is in motion, it is the force which can stop it. So how can we conclude? Force is the fundamental factor which can change the inertia of a body. So please try to go for the basic things of this inertia and Galileo sir statements. In our next class, we'll start Newton's law of motion. Newton sir has given 3 laws, and still that 3 laws only dominating the entire mechanics. So the mechanics is so many times called as Newtonian mechanics. It is the greatness of Newton sir who has formulated all the things of mechanics by his only 3 laws. Still then, please revise the chapter. Thank you.